Yeah, this isn't going to be, I'm going to do a little bit of an interactive session, but only about half the class actually has accounts on HPCC, but I'll talk about getting an account. But if you have questions, please. Just kind of a little overview about HPCC. We're the Center for High Performance Computing and Communications on campus, and we started in 2000, kind of with the goal of trying to become a global leader in research computing. We've got over 110 research groups that are actually using our clusters. There's 2 Linux clusters that we have, which I'll get into later. And we have lots of different kinds of storage systems, different groups use. We have free storage that's available to people. We also have dedicated storage that people buy. In addition, one of the big things we have as a push for us this year is our internet connectivity to different places. We're one of the first universities to have a 100 gig connection to some of the research networks that are out there, and we're actually the first group on campus that has a router. So we're planning. My understanding is we're planning on rolling that out to the entire campus and connecting the ISI and the health sciences campus together on a network, and also connecting to so this is on the webpage. This is kind of just an overview of what a compute cluster is. And the top right here, you've got your login nodes that you'll log into to submit jobs to or get job status. The other thing is people will do like compilations for the cluster on that before they submit them. Connected to that and also to all of our processing nodes down here is we have a bunch of file system servers which have banks and banks of drives for storage. Different groups, well, we have some that are shared among all the groups. We have some that are dedicated to different groups depending on what the needs are. From the head nodes, you're going to submit a job into a queuing system, and the queuing system that we use is called PBS. Actually, the version is actually Torque. Torque is an implementation. PBS stands for the public batch system. Anyways, and then there's a scheduler that takes all the jobs and then schedules them onto the cluster. So those two same things sort of work together to put your job on the cluster and have it run. In terms of access, HPCC is freely available to all USC students and faculty. You can apply to account here at our allocation request form. Only one person needs to apply. That's going to be the PI of the project. And they basically will manage all the adding and subtracting users and requesting for computational cycles or requesting disk space. Okay. Anyways, this is the web page for applying for an account. We have an application here. One of the things I was asked at lunch is actually you can have, for this you just put in your regular USC username and password. You can have multiple projects. We do have people that have them. So if it's the first time you've ever applied for an account, you would fill out this PI form just to give information about you, and then you would create a new project. One of the things that we do like people to do is if you please fill out the project abstract, methodology, and some kind of justification. We actually use this in justifying getting resources from the university, and it also gives us an idea of like what kind of things people are doing. And we like to contact people from time to time to give talks and things about that. If you don't know what to put in terms of core hours in this space, you can just go with the defaults and you can change them later on. You can always request additional CPU time for the 4 hours or additional disk space. All right. Anyways, for disk space, for the free account, you can have up to 1 terabyte per project of space. And if you need more disk space than that, you can talk to us about buying additional disk space. Or the other thing is there's also the USC Digital Repository is an on-campus resource where you can rent disks from them on a monthly basis. And that's also tied into the cluster. So all the data you put there, you can access on the cluster. And it's also available on the general internet and at other institutions who can share data. So this is kind of a picture of what a cluster looks like. Actually, a lot of people that use it have never seen what the data center is, so I thought I'd post some pictures here. And then we also give tours. If you're interested in a tour, you can just contact us. But basically, it's a rack of machines. They're all sort of shoved in there on top of each other. Our clusters, we have 2 networks going into them. There's an Ethernet network that's used for management, the job setup, and sometimes some of the disk access stuff. And then the nodes are all connected together here with a high-speed interconnect. These are our newest nodes that are going into service at the end of the month, and they are connected to what's InfiniBand. I talked about the 2 clusters we have. So our newest cluster that we built at the beginning of this year was rated the fifth fastest supercomputer in U.S. academia and 53rd fastest in the world. So we're pretty proud about that. It's made up of 264 HP SL250s. The one thing that's sort of unique about this cluster is it has these GPU accelerators. So if you don't know what a GPU is, it's basically a massively parallel computational system. So normally on a normal cluster, each machine will have 16 nodes or 16 cores, 16 CPU cores. GPUs usually are in I think these ones have like 2,500 cores, but they operate at a much lower clock speed, but they can do things parallel. So if you have something where you're going through maybe a lot of data or doing a lot of parallel computation, these will speed things up. We've seen people have like 10 to 20 times speed up when they move their stuff to GPUs. Yeah. One of the negatives about GPUs, though, it does require you to modify your code and program to the GPU, because the GPU has its own memory that's separate from main memory. So a lot of what you do if you have data is you spend time having to manage loading that data into the GPU, doing computation out of it. The new cluster nodes that are up here above, these are identical almost to what we already have, except for these don't have GPUs. We have actually quite a few people that aren't using GPUs, so these are cheaper. One of the other things is if your group wants dedicated resources, you can purchase nodes within the cluster, and these will be dedicated to your group. No one else will get to use them unless you want them to. And we sell them at the same cost that we buy them for, so we're not making any money off of it. And we provide support for speakers. And usually we buy in a big bulk, so we get a pretty good discount. Our other cluster that we have actually is still it's older, but not too bad. It's 13th fastest supercomputer in U.S. academia and 243 in the world. It's 5 generations of hardware, so that's about 5 years purchases here. And it's got a lot more machines, 2,185. They range in different speeds and sizes. So our oldest ones have 8 CPU cores and 12 gigabytes of RAM. Any questions? Okay, so I talked a little bit about the job lifecycle. This is a picture of a bunch of the racks with the lights turned, which we don't actually usually get to see unless they're doing photography brochure or something. So, but it's kind of good. But basically, you submit a job into the batch mode system with a PBS script, and it will go into the torque, wait for those hardware available, and then run your job, and your results back. So what happens then is you need to get put on a queue to determine when your job is going to run. So by default, we have 4 actually queues that are available for all 3 researchers. If you buy your own nodes, we'll set up a dedicated queue for you so that you would submit that. We because it's a shared resource, we have different sort of job parameters around them to sort of help people, to prevent, I guess, people from abusing and using up all the resources and allowing other people. So the main queue, which is what most people submit to, your job has to have more than an hour of wall time, so you request the amount of time you want your job to run for, but there's a maximum of 24 hours. So you can only run for up to 1 day. And you can have you can have one node up to 99. So if you want one node for a day, that would one. For people, we got a lot of feedback from people that saying, well, I'm sort of developing something, it's not really working, so I don't want to have to wait around. If you submit something to the main queue, depending on how many nodes you have, you might be waiting for several hours before your job runs. So if you're developing a new code and want to test something out, you can put it in the quick queue, and that's what we recommend a lot of people to do, but your wall time has to be less. So if you're trying something new, I recommend having a wall time of less than an hour, and you have to have less than. And then we also have a large queue for people that need to run very, very massive jobs, and I forget to pronounce what it is, but that's if you want more than 99 nodes, and the maximum of that is on 256 nodes. And you can only have one of those jobs running at a time. If you're going to do a large job, you'll expect probably the queue for, I would say, at least a day or two before your job runs.
How do you pick queues? From your VS script, or do you pick them from?
Actually, so for these ones, you don't have to pick anything. So what will happen is it'll go into this default, and then it'll look at the parameters that you gave for your job. So it'll route you to whichever queue based on which parameters you gave. And then we have another special set of nodes, actually the large mem queue. So we have some machines that have a terabyte of RAM available. There's 4 of those. And you can only run one job and use one node at a time. But you can run these jobs up to 336 hours, which I think is weeks. We have this here for people, but we recommend you don't run a job for that long. If you can help it, then you should check one of your jobs, because occasionally something will happen where the software screws up or there's hardware failure. And if you're running something for several weeks and it all goes away, lose all your results. It's very sad. And then we have a link here to our website, which has a little table. So you'll have to run it. Yeah, sure.
You talked about you had different types of nodes.
Yes.
When I run my scripts, I always put a processor per node.
Yes.
But I've seen there that there are nodes have more.
Yes.
How do I know which process? How many processors does the node?
Oh, we'll have.
Or can I always put more than 8? Can I put 16?
Yeah, if you put 16, the queuing system will only run your job 16 machine.
So I can put
16 CPU machine. 16 CPU.
I can put 16, but I have to wait longer.
You might have to wait longer, yeah. So it's sort of a trade-off as to what's available. So all of our new systems, the minimum they'll have is 16. Less than that. So if you want to run on the newer hardware, usually more 4 something. Most of the freely available queues, most of the nodes are 8.
So if I go to the main queue, the most the quickest thing for me, the best thing would be to allocate 8 nodes, 8 processors. No.
Yes, if you want your job to start running quickly, but there's a trade-off, and you can have a shorter queue time, but you might be on slower hardware. So your job might actually end up running slower than if you longer, but had more processors that are fast.
There's no way to know that.
You have to. It really varies job to job. It's not an easy way. We're actually been working on monitoring things for shows, sort of different competition, but we haven't got it to be shared yet.
Yeah.
To sort of see how long queues are. It varies. So the newest ones that we're adding this next week, so we're having next week, they're going to have 128 gigs. Or gigabytes. The smallest ones we have now are 12 gigabytes.
Say if someone was ignorant about the script that they were running and they thought they needed more cores than they needed, could the HPCC monitoring system say, hey, you're only using 1 core and 10 gigabytes of RAM, so it free up those cores?
Yeah, the way in which we're running it right now, We actually don't do that. When you get a node, you get the entire node. But
oh, you do?
Yes.
Even if you
ask for one core. So it's fairly wasteful. And so we've been looking at techniques to share nodes with people. Our biggest concern is we don't want one person's job to impact the person that's running on the same machine.
Well, I mean, just make sure that people specify.
Yes, but we have people that also they'll fill up the entire drive, which there's a lot of stuff.
Well, I'm just
ways
trying
people
to, just ways to prevent.
Yes, that's one of the things. We did some analysis a couple months ago, and most of the people who run jobs on our cluster are running single node.
So how come CMP can be another graph from the page, but that is
Yes.
more. And sometimes get other there are several colors, several users that are used.
So CMB is different in that you guys actually have asked to share machines, and so we have turned that on.
But I have never been able to. For example, I was finding a node, for example, HTTP 11.5.
Okay.
And one guy was working for after some very for just after 4 gigs. I have never been able to get access to 6 over of that. So I don't know how.
Oh, how?
Yeah.
It also could be. Well, I don't know. It depends on what they submitted.
You usually see many
Many empty ones.
many nodes that just want for it.
Yeah, we also see sometimes people will submit wanting more cores, but they don't use it. If you have something that's not running, though, you might want to email us about it. We can look into it. But that's one of the things. If you submit a job, it's better if you can let us know while it's running or while it's being viewed, because if the job's gone, it's very hard for us to figure out. Anyone else? Okay. So I was going to do. There's 2 ways to submit jobs. You can actually do an interactive job submission, and this is just sort of some text I saved for doing it. I'm going to do a live demo too, just to see. But interactive jobs, you will get logged into one of the nodes. The first one usually list of nodes, and I mostly use these when I'm trying to debug a script that I'm developing, because you can run all the same commands you have for script. So let's see. Let me just do this. Okay. Okay. So I'm going to log into the head node login 2. And this is just read the messages of the day every once in a while if you don't mind. But we're having a downtime. This is all the information about what we're doing next week. And that it's going to be. So anyway, so to submit a job, use the qsub command. Qsub. For an interactive job, it's a -I. And then you can give it parameters as to what you want for your job. So if I do wall time of, say, so that's in the hours, minutes, seconds. So that's 1 hour. And then I can do, I have node 2, and then I can give, say, ppn equals 8. So that's 8 cores. Can you guys all see this, or? Better. Anyway, so I have an interactive job. A wall time for 1 hour is how long I want to run. I'm going to ask for 2 nodes, and then I want the 8 CPU cores on each node. And so while this is waiting, I can actually go and look at what's the status. So after you submit a job, you'll get the job ID here, and I can log in with another term. And I can use the qstat command. Oh, there we go. So the QStat command for my job is telling me standard in means it's going to be an interactive job that I'm basically typing in. Here's my user ID, and then it shows you which queue I got put into. So I asked for 2 nodes for an hour, which will put me in the queue. If a job's taking a while to start, you can run the show start command and give it the job ID, and it'll tell you usually an estimate of how long the job will be queued starts. If you're trying to do an interactive job for a large number of nodes, it's kind of tricky because it could be a couple of hours before you get all those machines available to you, and your terminal just sort of has to sit around and wait. So it actually shows this one already started. So if I go back, now I'm on the machine and I can do whatever I want to run a job. You can see these are the 2 nodes that I have that are allocated to me. So once you have a job running, you can actually log into both of these machines if you want to. So like if I wanted to use like a different version of Python, we have a couple in user USC, which I'll talk about later. The Canopy stuff, which I think you guys are using in this workshop, we have under this N5. And so I'm using the bash shell, and in order to put all this information in my path and get it set up, I just run a source of setup script. So every software package that we build, we have a setup script for it. If you're using C shell, then you source the C shell. Great. So do Python, and it'll show now that Python I'm using is the directory. One of the other things in your scripts that you can use is there's a bunch of environment variables that get set. So if I do environment, and I'm just going to filter out the ones that say PBS on them. All these things will get set in your job, so you can use these in your script if you want to start up things on different machines or start up a certain number of processes on a machine. So like my PPN equals 8. This is how many processes that I could start 8 on a machine because that's what I asked for, and then I have a total of 16 total. One that's in here is PBS node file. So this here is a file that'll get created, and it tells me all of the machines that it's on. So if you cat file, what it will give you is a list of all the machines you're on, but whatever PPN value it put in there, it'll multiply that out for each machine. So you can use this in a script if you want to log into different machines and start up different processes on them. And I don't know, then when I'm done, just exit, and now my job's done. So, yeah.
So, when you use an interactive,
yes,
do you have to use the source command to specify what software you're using?
Yes, you should.
Now, I know that a lot of people, when they call a script in the job, a certain programming language, such as Perl or Python, like it's stored in their bash file.
So yeah, actually, when you do an interactive, if you put something in your bash RC file, that will get loaded in.
When you're interactive.
When you're interactive, it should be, yes.
So you wouldn't necessarily have to use the source command.
No, but I always do it just as a matter of sort of like correctness, because when I go from an interactive to a script, that bash RC is not usually loaded if you do a PBS script.
Okay.
So I always do it just to avoid any confusion. But I mean, it's...
When you say it's a PBS script?
It's actually my next. Let me... Okay. Anyway, so that's sort of the interactive. Okay, so the other way, which most people submit stuff, especially if you have a large amount of processing to do, is you do a PBS script. So this is one, since this was a Python tutorial, last week I was working with some noob stuff, and so I looked up, can you integrate Python into German? A bunch of stuff. And so I created this PBS script to count words within a bunch of different files, a bunch of different Gutenberg books that are freely available on the internet. So PBS script is, you start it off with what kind of shell you have at the beginning. You then give it different parameters on these lines that start with the hashtag PBS. And these all should be at the top of the script, so like starting right after your shell command. What will happen is the PBS system will look for these lines and pull them out and use that configuration. Yep. Oh, okay. So for large memory, if you want the large memory, the 1 terabyte boxes, we actually have a special queue for those. So you give a minus Q. Let me show you. If I wanted a large memory box, I could do Q sub. These might be in use, so I don't know if we're going to get one. And then you would give a minus Q large amount, like that. So this minus Q is for, if you have a dedicated queue, you'd also give a minus Q large amount. So I'm waiting on my jump there. On that, you see it put me in the large range. Another thing, if you're looking for, how many large memory boxes are available. Oh, so you have, your own group has its own queue, but you have a box with large memory, or you want one with big?
We have our own queue.
Okay.
So that our queue doesn't support the large memory. If I have to run large something from I have to go to the large memory queue.
Well, if you want to use our large memory boxes, you just do minus Q large for that. If you guys have a large memory box, you probably do what I have on the other here. You would give how much memory you want, and then it'll try to find a box that has that amount of memory that's free. You give it this memory equals 30 gigs or whatever you want, 256.
But if I want to use your large memory,
yeah, you can use. So all of the sort of freely available public nodes are available. That have to. Yes, if you have bots, it'll get charged back whatever accounts you already have. But if you've already bought nodes, you can use the.
So you don't get charged extra? I mean, I just want to confirm.
Yes, there's not like an additional charge.
So it's part of the package if somebody's lab buys something, you're just like, unless they're overusing them or something.
If you're overusing and dominating them, you might talk to. Maybe you should buy some more nodes, something like that. The charging is the charging we do is actually more for us to report like how much usage people are doing. So the university can say, this is how many projects we have, this is how much compute time.
So you don't really mind sometimes.
No.
And because it helps you get.
Yeah, and from time to time, like we know people that they have projects that come on and they have a deadline they're doing. Be like, hey, we need to run this stuff.
Okay. So just contact.
Yeah, if you want to use a lot of nodes for a certain amount of time, and sometimes we've dedicated those. Usually we only want to do that for a couple of weeks for a very long period. Our goal is to get people to use this stuff or to support all the research we can. Not trying to make money. And the more you use it, then the more we go to the university and say, give us more money. Okay, so where was it? Oh, so in this script, just sort of pointing things out. These come at the beginning of the file. Here's my wall time, which you've seen before. You can actually put the -L with commas if you want. Usually in the script, I separate them out. I'll edit them off. It's easier to read. This is asking for 2 nodes with 16 processors each. Here I added this is an extra feature, which is the IP feature. So like I said earlier, we have the new cluster, which is InfiniBand. We have the older cluster, Internet. So the IB will make you run on the InfiniBand cluster. You add that. Another thing you could add is if you want GPU nodes, you can do GPUs equals. Each of our GPU nodes has 2 GPUs. You can use one of both. Here. And then there's other things within PBS that you can specify as well. This means I want to have a node that has 31 gigs available.
Just if that's your tool that you may have
yeah, for
separately must.
For CMB, it's more strict because you guys are sharing nodes. And so PMEM is another setting which says how much each of your processes on the machine are going to use. And so it needs that, since the nodes are being shared, it needs to about how much resources you're actually. Yeah.
I never. What happens if I don't find IP?
Oh, so if you don't put an IP in, it'll run on either cluster. So if you don't care, that's fine.
IP is big.
IB is the faster hardware, and it has the faster interconnect. So the InfiniBand is 56 gigabits, so the machines will talk to each other at 56 gigabits if you're doing a lot of inter-machine communication, whereas the MirrorNet is only. There's some people that run software that only runs on InfiniBand, and so that's why this is here. There's some people that only run the software that only runs on InfiniBand. Well, really depends. Yeah.
Do you have to know at the Genome Center if whether or not they share like CMC?
I don't know actually. No.
How would if they're not, like, how can you transform or change it?
It's settings that we do within the queue. So the PBS software allows you to share nodes. It's just that we have this problem. If you do share a node, then some users can interact, can affect other users. So yeah, it's really up to.
Sorry, if you don't that IID,
Yes.
wouldn't it run automatically on that bus? That's the only one that has 16.
Actually, we have some MirrorNet machines that have 16 ports as well. So it could run on either one.
Okay.
Anyway, so here's my. This is sort of all the job specifics to set up, and then this is just regular bash syntax here. I always like to add like when things stop, and just so I sort of know. So here I'm sourcing what version of Python I want. This one is actually going to use Hadoop as well, so it'll source the Hadoop setup information. We've created this script. I don't know if anyone here is yet, but it seems to be something. This will set up your entire Hadoop system within the nodes that you've allocated. And then I CD into the directory that I created that has my information. rsync, I don't know if you guys covered this, but this is basically a way to copy data between two locations. So I have a data directory which I copy to the Scratch file system, and I'll sort of talk about this a little bit more, but the clusters have different types of storage that you can use, and Scratch is a file system that's set up between the nodes that you get for your job. So the nice thing about that is no one else uses that file system, and so if you need to share data among your nodes, you can just write it there and they will all see it. The one drawback is this gets destroyed and recreated with each job. So after I run my job here, this count word script, then I copy stuff back out. And then I echo this back out. So if you're submitting a job like this, one of the things when I created this is actually, by the way, I did get a node here, and then I ran for more than my 5 minutes. So when I develop these scripts, this script, I actually do it interactively. So I take all those lines, run them one after another, make sure it sort of runs through. So if I want to submit my script, let's see. Yeah, okay, so here's the food stuff. The count words script that's in before, this is basically just another script that I wrapped around, which sort of starts up my Hadoop process and passes in Python modules that do map reduce on them. So, and where was my, here's my count words PBS that we saw before. And so just to submit this, I do the same QSub, and then I just submit that in. And it'll give me my job ID back. And it was put on the quick queue, and I'm waiting right now. If you're curious to see what else is running on the queue, I was wondering, what was your command? The QSub. Oh, I just cat just it'll spit out whatever file you have. Oh, I was just showing what the script looks like. Okay, yeah. So that just puts it to the screen, the cat command. Yeah, it'll just whatever text file you have, it'll spit it out. Okay. There's also less. It's nicer because then you can scroll up. These are just using commits. And then, could you real quickly say what the rsync does exactly again? Oh, rsync is a copy command. So if you have two different directories and you want to make sure that they're identical to each other, you can use this command called rsync, where it'll basically take any files that's in this directory that aren't over here and copy them over. Okay. See, I see that you go to a certain directory that you're allowed to work out. Yes. So it doesn't run from the headset. And then you have this rsync, AQ data, and Scratch. Yes, so I'm copying my data. Rsync. So if I use the Scratch file system, which I'll talk about a little bit more later, but you have to copy, remember to copy your data back. So if you ever use Scratch, it's going to go away when your job finishes. So before your job is done, you need to copy it back.
What's the advantage of just simply pointing the output toward where you want to have?
So it depends on how large your simulation is, but if you're running something on 100 machines, and you try to store everything back in your project directory, you can open one. So that's the main reason. So usually we recommend people write all your data to Scratch, and then at the very end have something to put yeah. Oh, if you do QStat, actually, you can see everything for all the queues. So if I want to see, like what's running in the quick queue, you can just grab it. And there's actually anything that has a C here, that's actually a completed job. See here, my job completed, it only took 1 second. And if I go, I look back at my PBS script. So I'm copying out this rsync. It's going to copy out my results, which I stored in /scratch results, to this location. One thing is if you're running a lot of cluster jobs, when you name files and things, you might want to, I usually put like a date string at the end of them so that I don't actually accidentally overrun previous results. So what this is going to do is it'll copy everything that's in results into my project directory with the directory name for results, but with the date. Yeah.
What did you just do to find out how many results are by everybody?
We actually have a page we have a page on the website that lists all of them, but it's kind of difficult to read because the grouping that was done is done by name, and what expected to by the group.
Any command I tried some of them.
Yeah, there's nothing that's, well, oh, 5 more minutes. Okay. I can give you something after. It's actually, you kind of string something. Or you can just always ask. just send an email to hbcc@usc.edu, and that's an easy thing to answer. And if you keep asking us, it encourages us to make it more publicly available. So, anyway, so that's kind of that. Oh, let me just talk about best practices, because I got 5 minutes left. The things just to think about, a lot of people, when they go from running stuff on their local computer to running on a cluster, they don't realize that every little thing you do is magnified multiple times. I talked about some of the storage things. So user and project file systems, every user has a home directory that's only 1 gigabyte in size. That's actually not very big anymore. But we can't make that bigger because we want everyone to be pushed into project directories, which we can. So if you have a project, your project directory can go up to 1 terabyte and buy more if you want. If you think you've run out of disk space or you're getting weird errors, you can always check your quotas to see how much space you're using on both your project and user directories. I talked about Scratch, which is a place you can store stuff during a job, but you've got to copy it out. We have a lot of users that have been asking about having a temporary storage location that they can use between jobs. And so with the next downtime, we're creating this thing called staging, which is a large parallel server farm that will be mounted on all the nodes. Every project will have space there. This is about 300 terabytes total. We're not putting any quotas on it, so people are free to use it. But we want you, if you don't use data for more than 10 days, it's subject to be up. So it's something to be used like while you're doing jobs, and then once you have the results you want, you should copy that back. So some other things that we see, if you're running stuff on a smaller scale and you scale it up, sometimes people go from having hundreds of files to running something on the cluster where they have millions of files in a single directory. That's actually very, very bad because the system will start spending so much time trying to figure out what all those files are and actually being able to access them. So you want to think about how big your files are and sort of minimize the number of files you want to have in a directory to be thousands of both. Because doing just an ls in that directory will take multiple minutes to hours because it has to do all these lookups for every file. So other things is at some point if you have a lot of small pieces of data that you want to store, you might consider storing it in a database, like dumping and loading. So if you have questions, you can always email us and ask too. The software, we have a lot of software packages we support, which are all installed in user USC. They have a setup script that you would run to use them, which will have just easily. This is kind of a list. If you have something that you think multiple people would want to be using, to sort of just send us an email and ask if we can install it. We'll sort of determine. We like the support. But under each version, there'll be a setup script inside of it. So it'll be setup.sh or setup.csh in that directory. So you would just source
that setup script from my login now?
Yes, you can do it from login, or you put it in your PBS script.
Oh,
directly. So at the beginning of your PBS script, do source user USC r / whatever version number / setup. Right, to make sure.
So Perl.
There's also Perl, there's a lot of software that's already installed with the operating system. So that we have in a separate one. But people have asked for like newer versions of Python. We have newer versions of Python there. R is big with that. If you want a newer version of something we already have installed, just ask. We also keep a default link in here. So if you want to do user USDR/default, these default links, and we also have a newer one. These only change at downtimes, so they'll stay pretty consistent. But if we add like a newer version, like this 3.01, we don't want everyone forced to use 3.01 right away. So you can just you can source user USC our default. And I don't know, it's just more pictures. Another thing, which they'll probably talk about more with with workflows, is you want to try to design your stuff so you can checkpoint and have job recovery. So try to write stuff out every once in a while or divide things up into smaller pieces so that you don't lose all of your data if your job fails. You are running on commodity hardware and it does fail. And we actually have workshops too, so you can go to hbcc.usc.edu, we have workshops there. Or you can email us at hbcc@usc.edu. edu and try to get back to you.
Okay. Sure. When I run my GPS scripts, sometimes I want to print out things on the screen in order to see how things are going. But if I just put echo something, it will not appear on the screen of my GPS.
It'll show up out.
Yeah, it'll show up in the output, but not on the screen.
You can't see what's happening live.
Yeah.
You can't track how your code is running, like if it's...
Okay.
Yeah.
So, well, I'm kind of out of time.
No, that's okay.
Okay. I was going to say, do I have... There's actually...
You could put out files like while it's running.
Yeah, that actually is getting stored to an output file on the first node in your list of nodes. Let me just try. It'll start quickly. Anyways, Torque stores all to a file, and so while your job is running, you can log into first node this list of all your machines, I know job, and under its var spool Torque, I think jobs. I'm going to double check, and then it's the name of your job ID, and that's what will be storing all those that echo information. You can actually go into that file.
Does that automatically get refreshed?
No, you'd have to like cat it, or you could do a tail of it. Every time it gets updated, the tail command will show you anything like that.
I'll
push it for you.
What was the syntax
To see just a file.
To see that live file of the first node, I don't know how.
I was going to try to show it, but it's going to take a while.
So do you have to go to a certain directory and then find and you said use a tail command and then cat your file, or what's the order of?
So I can get on all the machines. Maybe I can. So if you go cd into var spool, or it's spool. Oh, nothing's wrong. Let me try this guy's one.
You and that part.
Yeah, so var spool Torque. So I'm on the machine here, 1167, and there's var spool Torque, and then it's spool. Yeah. So these are the two files that will get saved off afterward. And so this OU is, if you echoed something out, that's what gets stored.
Yeah, and we can add it also to the nodes, the directions of where to look for.
Oh, yeah. So, anyway, so if you do a tail minus capital F of this while you're logged in, I can't read his file.
Maybe it's a good thing, right?
Yes, that's actually true.
Could you just quickly press up just so I can just... Okay, so you started at...
So into var spool Torque, and then into spool again, and then there's the job ID.
But I thought so when did you get into that?
Oh, from the head node? Sorry. I did SSH into the...
So you saw the node in which we would see, like, how do we know what node our job is
So
on?
if you give it -N to QStat, and then, let's say I just want to put it on. Oh, okay. It'll give you the nodes.
Oh, and then you say SSH.
And you SSH into the node, yeah.
And, okay, because you look at that, it was like SSH.
The history of this?
When you did the...
So then I just
SSH that.
And then the node name.
And then you can say, okay.
And then you do CD, var spool, then go into spool, do tail.
Okay.